Hello and welcome to the channel where we are building a video game from scratch using Love2d and Lua. Yesterday we worked on some falling animations for our character when he falls into a pit, like that. The only thing is it's just looping every 3 seconds. We don't actually have any detection going on for that. So, we're gonna need to fix that. Now, there's one thing I want to do before we get started, and that is to catch... Oh, well, never mind. I do want to address, it's 2 a.m. I normally stream at 7 p.m. I had a hell of a day fixing my computer. My CPU water cooler crapped out on me, and it's been over almost 2 weeks for me to get the replacement part and get it installed and everything, and it's just been a headache. I got it installed. We seem to be stable temps on the CPU. I've got them up here so I can peep at them. I think we're okay. Our stream crashed just 10 minutes ago. I went in and I changed some settings in the video encoder. Shrunk the resolution a bit. I'm hoping we're stable. I'm really hoping we can be stable. I'm gonna have to cancel paying for my internet if we can't be stable, but let's get going. I guess I preface that because I'm sleepy. It's 2 a.m. I don't know how productive it's gonna be, but we can see how far we can get. So we're gonna be adding some collision detection for this pit, right? So right now we're drawing this pit. It is a tile ID of 14 on our master tile sheet. So we need something that compares our player's place with any pit that is on screen. So we need to basically take our current scene's dot pits, right? Dot pits, and I'll show you what dot pits is. I always do this. I always type E in the chat. Can I get an E in chat, please? E is my exit alias for terminal. So let's look for dot pits, because that's what we did yesterday. We gave ourselves an empty table of pits for every map, but then we also, if we look at our dot pits, we've got in our data downloader, we're saying, okay, if the tile ID is 14 as we insert it, we're going to go ahead and insert a 2 entity table here, and it's got a row and a column, and it's a scene row and a scene column. So what that means is on our screen here, if there's no pit, there will be an empty table. If we go to a screen with a pit on there, in this case there's 2 pits. So now we've got 2 objects, a row and column for each pit. So this pit is the 5-3, 5 is the row, column. Yeah, 5 is the column, 5, and then row 3, which is 3 down. Then this one, column 8, but same 3 down. So we have access to at least the columns and rows for each pit. We need to calculate this into a pixel calculation so that we can do some AABB collision with our player. So first and foremost, if we get AABB collision done, and we can get that by either just printing a boolean if it collides with pit, say true, else do false. If we get the collision working, then we can start to add little rules, like we want, if you're at the edge of a pit here, it shouldn't trigger you to fall just yet, but it should drag your gravity towards the center of the pit. And you don't trigger a fall until your character is right here, right there. If once your character gets drugged to the center, we need to trigger that animation. We need to deduct our hearts. We need to respawn our player. Probably do the flinking flash that we've got for when geckos hit us. So look at this flash we've got. Yeah, so we've got that flash going. So we need to maybe spawn us with that red flash. Maybe add a death sound, something like that. So first things first, let's do AABB collision on any tile that is a pit. So we do have access to the row and column for every pit, so it's almost like we need to convert it into two you know, in X and Y position so that we can compare our player's X and Y position for some basic collision. So where would we do this? Like, we've got a map class that holds all the current map sprites, right? We've got a scene that holds the current map as well as the next map when we're transitioning. But we need to do, I think, I want to say we want to do it in our map. Yeah, let's see, because we need reference to our current position as well as, do we have a dot pits? We do. So we're assigning the dot pits from our global map declarations, and we're assigning it into the current map. So we do have access to the row and column for any given pit object in the current scene. So the kind of tricky thing is like if there's 50 pits or whatever, we'd have to check collision for every single one of those pits. So it's almost like, you know, we've got to loop through this self.pits, and for each one, we go through the row and column, we convert it into a pixel value for an X and Y, then we do AABB collision against our players X and Y, just straight up classic AABB, and then we could do something. We could render to a Boolean, or we can print, or we can, you know, render a red square over any time we're colliding. So let's see if we can get that working. So let's not worry about looping through each one, but let's go in our update here, and I'm just gonna add it to the top of our update. It's whatever. We can move it to a better spot after, but what I want to do is first we need to go into our self pits, right? We need to go grab one of the pits. And once we grab one of the pits here, we need to save it. We can say, we can just make a local pit, store it, store the first pit. Now, ideally, we would cycle through all our pits to do it. Let's just try to get one working, then we'll get two working. So boom, we got pit. So what would happen now if we've got the first pit index? Now, if there's no pits in the table, a pits 1 will be nil. So I'm thinking this might give us an issue right off the bat if there's no pits on the screen. But let's see if we can just print what this pit is, this local pit. So let's just say here we're going to say love.graphics.draw, and what we're going to, or .print, and what we're going to print is our actual pit. But what we'll do is we'll say pit, then we'll concatenate it to a string version of what that pit is. Now we can't, since it's a table, I don't think we can do toString. I think we actually have to do inspect. So we'll do that, inspect pit, and we'll give it an X and Y. Let's just say 10 and 10, whatever. Let's also give it a color so we know we can see it. So we'll say set color, and we want to give it a pure white, I guess. Hey, Elemental, thanks for the first time chat. Welcome in. It's going good. I mean, it's very late. I normally stream at 7 p.m. my time, but I had to fix my computer, so I am a little loopy. But we are working on doing some collision detection for some pits. I exactly thought this would happen. I definitely thought that would happen. Now, I'm kind of curious if we go to where our player spawns. Yeah, I think if we go to where our player spawns and make sure we spawn in a scene with a pit, aka 8.2, not 7.2, I think it won't crash. Well, it crashed. So, there's that. You know, every once in a while I feel like I'm getting the hang of it and then just slaps me in the face, but that's okay. We'll figure it out. So let's go to our map. And then we will make sure our dot pit is like looking pretty good. Where did we not do this in the map? I could have sworn. Oh, we do it. Yeah, we don't want to do it in the update. We do want to do it just here in the load. So let's add it there. And then all we're doing is taking the first pit, assigning it to a variable, and then trying to print that up. Inspect pit. Yeah, let's see. Wow, that freaked me out. Hey, thank you for the follow, Shaky Coder. Welcome in. Yeah, I can't use inspect. Okay. Well, I have been using inspect, so I don't know why it's mad at me. Let's just do a toString here. Oh, and you know what? It probably can't concatenate something inspected. I don't know. Okay. Okay, well, it looks like pit is just nil. Which should not be the case, but also I don't think we can concatenate a string, a table like this, which is why I thought we needed inspect. Now, if we take a look at our play state, we should have... We should be using this inspect. Yeah. 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 All we're doing is yeah, we're doing the same exact thing. So, we do... Oh, it's local. It's local. So yeah, maybe... for now, we'll keep it local, and we'll just import one into our map class for now. So we'll give us inspect. That shouldn't be nil anymore. And then when we print up pit, we need to say inspect pit 1010. Yeah. Let's do that. Okay, still nil. We do have pits though, so don't know why this is nil. If we go, actually, yeah, if we go into hold our 2 debugging, see we've got 2 pits there, so pits at index 1 should be this first table that we're inspecting. It's not working like that though. So let's make sure we're doing something. We've got self pits at index 1 saving into local pit, and we've got a dot pits pulling in from the map that we're currently in, and that's what we're printing up on the 2 debug. So self dot pits. Did we do self dot pits at the end? Self dot pits index 1. Okay, well, let's just say self.pits gets local pits. I'm going to be sick of saying pits after this. I'll tell you that much. Okay. Pits. Let's see. Still nil. Still nil. So pits ain't nil. Pits is nil. Now, I think... Dude, I mean, as long as we're doing pits... After we assign it, which we are, you know, this is in the init, the map init gets pits. Let me just try something. Let's try to pass in the global map pits and see if it's any better. I don't know why self.pits is not liking it, but we'll try to do it right here. We'll say local pits gets our map and column pits, and then we go inspect pits. That sounds so weird. Are you experienced in Lua? I'm 1 week in and loving it. Coding for Playdate. I don't know what Playdate is, but that sounds cool. I made an arcade game in Lua, and I made a little board game in Lua, and this is my 3rd game in Lua. So it's been a couple years, but also, you know, in game dev time, that's like nothing. So I would say I'm decently familiar with Lua, but yeah, not great at it. Still learning for sure. But yeah, what is a Playdate? I don't know what that is, but it sounds kind of cool. Thanks for stopping in, Shaky Coder. I appreciate it. Yo, pits is still nil. What? is going on. The only thing I could think of is something wrong with the init, like... I mean, if we go to where we did this pits assignment, okay, not this. We need to go back to our map class. Yo, why is pits empty though? If we do self.pits and inspect that. Okay, so that's not empty. Self.pits ain't empty. But if we go self.pits index 1, not empty. So what the... How come when we assign it into a variable, we... Pits. We say pits. We go to the top of our... where do we do it? Pits. Yeah, we get local pits. Now, is local... You know what? We've been doing this all wrong. How do you publish your games? I post all the source code to my games on my GitHub. I think I've got it here. So I do have a build as a release. So if you go... It's not the current one, but it's from maybe a couple months ago. And if you click on releases in the GitHub, there's executable builds for Mac, Windows, and Linux. So whatever you're on, you should be able to play it if you want to play it, or you can compile it or interpret it from the source code. If you download the Love2d game engine, you just drag and drop the folder with the main.lua in it, drag it onto the Love2d icon as your shortcut, and then you'll be able to play the game right there. So I do post all the source code for my games, and I got a couple other games in Love2d and Lua also on there. Like if I can show you on here, if we go into Joust, we can run Love dot on Windows. It's Love exe dot, and then we can play Joust. So this is the arcade game I built in Love2d and Lua. This is working on Mac, Linux, and Windows, whatever you're on. There's like 25 waves. There's a high score table. And then some stuff happens, like lava rises, bubbles, different bad guys, and all that stuff. So this was my last project. Took me like 2 years. 2 years to make this game. But I learned a ton. You know, I reconstructed this game. You know, I didn't follow a tutorial, but I had the actual emulated game to play with and kind of like see how they did some stuff. So I had to do some like getting the skidding right, getting the animation right on all that stuff, all the collision detection and saving scores and high scores and all that stuff. It taught me a lot. But, you know, I'm glad to be on my own project now, you know, my own original game I'm trying to build. I mean, I am kind of emulating it, you know, off Link's Awakening, but at the same time, I get to make all the rules. So, like, in our game, you know, we don't have a little sword and shield, but we do have magic spell casting, so we can cast a magic spell, and then we don't ignore the perpetual falling, but we can cast a magic spell and cleanse the geckos, and our gecko animation is jacked up. Oh my god. We'll have to fix that. I think something we did. Oh no, I think something we did with our why do they actually... Oh, we got to set them to looping. Let's do that real quick. We'll just go... we changed our animation class to default to non-looping. So in our entity defs, we just have to say looping gets true for all these, which is kind of a lot to do. But if we go... Yeah. Any... Does that mean that when we walk, it doesn't loop? No. Oh, it does. Yeah, we don't loop on the walk either. So yeah, we gotta fix this. It's not hard. It's just kind of sucks to do a bunch of Yeah, the code, I had a thing like, hey, if you don't declare the looping, default to looping. And if looping's false, then go ahead looping false. But that was not working. So I had to add in manually say, okay, no, if it's looping false, make it looping false. But now I also need to say, hey, if it's looping true, this .def will be assigned for each one. So all we gotta do is just we could do maybe a macro of like 5j paste, 5j paste, and then this is why I like Vim, but doesn't always work. You know, it gotta be 5j. Oh, I did 55j is my issue. But yeah, we basically got to make sure anything defaults to looping true. So we'll do that. Not right. Not right. Okay. I don't like that we're doing this. I don't like that we're copy and pasting this, but I tried to do it the right way. Wasn't working, so we got the getaway. Okay, if that fixes it, I'll be happy. Chances that fixes it. I'm hoping it fixes it. Let's see. Okay, and they're broke. They're broke. They're broke. Yep. I get it. Yep. Yeah, we gotta loop them. Let's go into our entity class real quick, and we'll see if we can find this bug and knock it out, because that is not okay. We should have a .looping for the animation, which I'm not seeing. Maybe it's in our entity walk state. What? Nope. Let's just grab search for looping, and oh well, we've got a bunch of them, so right here. Yeah, looping gets whatever we define looping to be. And we just made looping true on all that stuff. So it should, I don't know, it should be working. My game's monetized. Nope. My games are free for everybody. So I try to, post the source code for anyone to check out and tweak if they want, and then I try to build the game for Mac, Linux, and Windows so that anybody can play. There should be no barrier to entry to play my games. You just gotta have a computer and a little bit of know-how, but yeah, that's kind of my philosophy. This is jacked up. The looping should be fixed there. Now, I guess what we can do, let's see if our walking isn't looping either. Dude, our walking isn't looping either. Okay, I think I know why this is happening. I think I know, and it's what we did last episode. We need to go into our animation class and see how we're doing this. We're breaking out if times displayed is greater than 0. That is wrong. So we should be doing, this is the only one we need to play. Anything we need to play once, we need to return. So we can say if, where do we say like the type of animation this is? Because I bet if we turn this off, it would fix the issue. Let's see. And now we are walking and looping. So, okay, so our geckos should be fixed now, but what isn't fixed is that we aren't resetting our, yeah, so the geckos are now walking, so that's cool. Okay. Oh. Okay, so the issue, the thing we just fixed is that, actually, that isn't bad, because we change, okay. You know what? Yeah, that's actually not bad. We had to do that fix. So look, like we're facing down, every time we die, but if we face a different way and then die, we face that way. And you see it kind of like comes in and then changes. That's okay. Yeah, we had to change that at some point, because the first frame, if we don't return, you know what? Yeah, we'll just get rid of it. We'll get rid of it. We had to return to basically break the loop, but instead what we're doing is, where are we doing that? We're changing our player's animation to be whatever direction it's facing once we've finished the animation. So there is a line that we're doing this at, and let me just see. I want to leave me a little note here that says like probably delete. But I do want to find where we're doing this. It would probably be under change animation for our player walk state, maybe. Wow, I'm a little lost at when we do this. The fact that it's 2:30 in the morning might be the reason I can't think so straight. But it's working now. So at least I can do that. So and we're still able to test the falling here. Every 3 seconds it'll loop and it brings us back. Sweet. I'm not seeing where we change our state though. I'll have to find it later. I'll leave me a little note so I remember to come back to it. Oh, and you know what? We actually got rid of the .notes.lua in terms for a text. Okay. I'm just going to say that we need to find where we reset Tashio's animation. Upon falling frames playing. Okay. And then... Okay. Let's work on some AABB for pits. So we have to go into a local, or we have to go into a global state for this pits. So let's take out local pits. We'll say local pits gets self.pits. And then we will inspect our own pits. Actually, just pits, because it is our own pits. So pits should be pits. We've got pits. Okay, so now what we need to do is, now that we've got access to the pits of the current frame, and it's like, you know, over here there's only one pit, so we've only got the one over here. Now I do want to see, we should be able to say, hey, pits at index 1, that's the first pit. It should be the first pit. Cool, 5-3. The next one should be 8-3, so if we go to index 2, should be 8-3 pits, 8-3 pits. Cool. So let's... we've got our pits. We need to convert these into X and Y position. Our tiles are 16 by 16. So we will convert them to an X and Y because we have their row and column. And then we will do AABB collision based on a square that starts at, you know, whatever the things are. Whatever the position. Okay. We'll go up to the top of our map and we'll say, okay, as long as we got pits. We got pits. We don't need pits. We could do self pits. Let's keep going. I mean, let's just say, let's just worry about pits 1. Okay, let's just try to do collision for pits 1. Now, the first thing we need to do is go into the column and convert it to a... Let's see, column is, you know, how far left. So we would say, what we would want to do is take what column we're at, Yeah, and we would need to multiply by 16 because that's how wide each column is. And I cannot type a 6 to save my life. Okay. So we multiply the column by 16, and then we just can say, you know, it's tough because we need multiple ones of this. Because there could be like 5 pits on one screen. So for now, I'm just gonna make a global, and we'll worry about trying to pull it out. What I'm gonna do is say, I want to say pit X is gonna get how many columns we have on that pit times 16, and then we're gonna say pit Y is gonna get the first pit's value dot row times 16. So that should give us the top left position of the pit in pit X and pit Y. So what I want to do now is just check that that looks right. So we can take this off and we can say, you know what, I want to see not only our pit X and pit Y, but I want to see the characters dot X dot Y so that we can verify if that is looking like we did the arithmetic correctly. Because it's actually, let's see, if row is 1, yeah, you know, we already did it wrong, because if like, let's say we're in the top left grid, row 1, column 1, our current algorithm is saying times the row and column by 16. That would give us a 16, 16 for a Y and an X position on our pit, even though the pit is at grid 1, 1, and the top, you know, the drawing quadrant of that pit 1 should actually be 0, 0, because it's the very top left. So we also need to subtract 16 from the pit X. Yeah, we need to shift it by 16 so that we account for the non-zero indexing that Lua has got. Cool. So let's go see, and we will print up pit X, okay, as a string. We'll say pit X, and then we will concatenate to a string our actual pit X, and then we'll place it at this X and Y of 10, 10. That is the first of 4 values we need. We also need to change this to a Y. We need to change this to a Y. And then we need to change this to a 20 so that we can see it. And then we need 2 other values. We need player Y. Didn't mean that. And then we need player X, and we'll do player X then Y. Okay. Now our map should have a reference to our player, and I think it is... Shit, man. We don't have a reference to our player here. That's okay. We can get around this. This is, you know, we don't need it in the map. We do need it in the map itself. Never mind, never mind. Okay, what we'll do is we'll go into our global scene view that holds a reference to our current scene that we're looking at, and we'll go into our, let's see, I think if we look in our scene, we should have a dot player. Yep, dot player. Okay, so it is dot player. Let's go back to our map, and we'll say scene view dot player dot X. And then we'll make sure it is beneath our other value here. And then we will come in here and we will actually just replace, we will substitute every X for a Y. Global, that just was not right. That was not right. Okay. Find X. Okay, and then 40. Yeah, it's late. It's late. It's late. Let's see. All right, 202 subscription, Yep. We need a X and a Y. Okay, we need to close our string. Okay. Sweet. Okay, cool. So we're printing up pits 1. That's this left one. So our X and Y should be the same values if we're right on top of it. And it looks like 64 and 32. Cool. So we look to be getting the positions, and now that's all we need to do a typical AABB collision. So I do like the tricky thing is we've got multiple pits, so we need values. We need, you know, a table of values for each pit we've got, so that we can compare the player with every single pit, see if there's a collision. So we need to be able to do that, and then we also need to render some sort of feedback to make sure we're detecting a collision for a specific pit. So we'll maybe do we have access to the pits X and Y, so all we'd have to do is draw a circle at the X and Y with a width height of 16, and then we'd be able to detect some rendering. So detect some collision. And that wouldn't be detecting it, but that would be allowing us to see if we are detecting it. So it'll be real easy to do this. It'll be real easy to get one working. It'll be harder to get every pit working. So let's start with one, and then we'll go up. Okay. So we've got pit 1, right? We've got pit 1. We've got the X and Y. That's all we need for AABB. So let's write to AABB. We could pull out the player X and player Y from the scene view separately in the variables to make it a little more readable, but that's not strictly necessary. Yeah, especially because, yeah, you know what? I do think with AABB it can get messy to read. We don't really need it though. Let's just try it. If it gets nasty, we'll fix it. Okay, here we go. Update. Okay, how do we do AABB? Well, we need to check. We would need to say, give us a value, you know, is colliding with pit. But it is a specific pit, so let's just do it for this one. We'll say is colliding with pit, is pit collide. And we'll say, we're going to default to not pit collide. Then we'll check if we're pit colliding. So we'll say if the left side of our player, so we'll say scene view dot player dot X. We want to see if the left side of us is greater than the right side of our pit. So we have our pit X. So we'd say the right side of our pit would be our pit X plus a tile size, which we have access to right here. And then, yeah. We're going to check, basically we're checking everything that is impossible for us to collide. So like if the left side of us is greater than the right side of the pit, and the right side of us, which would be our scene view dot player X plus player width, so scene view, and this is why I say to like pull it out into a separate variable, because it would be easier to say player X plus player width instead of scene view dot player X plus scene view dot player width. But we're going to see the right side of us is smaller than the left side of our pit, which is just pit X, and the top of us, so scene view dot player Y, would have to be greater than the bottom of our pit, which would be pit Y plus a tile size, and the bottom of us, so we'll say our scene view dot player dot Y plus scene view dot player dot height. The bottom of us would have to be smaller than the top of our pit, which is pit Y. If all those are true, then we have a is pit collide false, and then otherwise is pit collide is true. So we, let's see if that gives us an issue. Yeah, okay, we're good. Okay, so we should have this variable. Let's see if this AABB is working by just printing up the isPitCollide. So we're already printing up some stuff, so it's just gonna come up here and we'll change what's inside the parentheses here with pitCollide. And then we'll change what's in here with isPitCollide. Cool, and then we'll just make sure this is a frame below us, and we will see we're colliding, and we're still colliding. All right. Okay, so not quite right. Now I don't like that it's wrong. Yeah, you know what? Well, let's take this out of the update, and we'll just say, okay, we're gonna load it as false. If the, okay, so we're always true. So if, let's just walk it through, you know, if the left side of us is greater than the right side of the pit, and the right side of us is smaller than the left side of the pit, and the top of us is greater than the bottom of the pit, and the bottom of us is smaller than the top of the pit, then there is no collision, otherwise true. It looks right to me. Now we do like spawn in it. You know what? Are we? Yeah, we're doing this in the update. Yeah. And our pit X doesn't change. Yeah. Pit X, pit Y don't change. Just ours. Okay. So we're just doing it wrong. We gotta pull out. We could do. Let's try the opposite. We'll just define for a pitCollide, and we'll see. So like we know it's a pitCollide if the. Man, I feel like I should have gotten that. If scene view dot player dot x. We want to see if the left side of us is smaller than the right side of the pit. So left side of us smaller than the right side of the pit, which is pit X, plus our tile size, which is 16, and the right side of us, so our scene view dot player dot X plus the width. The right side of us would have to be greater than the left side of the pit. So pit X. And all these have to be true to be a collision. So then also and the scene view dot layer dot Y, the top of us would have to be smaller than the bottom of our pit, which would be a pit Y plus a tile size. And the bottom of our player, so Y plus, player dot Y plus a scene view. If we mess up any of these, it's wrong, you know? So like we gotta make sure we get it right. The top of us would have to be bigger than the top. No, the bottom of us, like this. Yeah. So we have the top of us needs to be smaller than the bottom of the pit. Then we have the bottom of us would have to be greater than the top of the pit, which is just pit Y. If all those are true, then we would say isPitCollide gets true. Else, false. Let's see. There we go. We've got collision for the pit. Cool. So what we can do here is now that we've got collision based on a pitCollide, we can say, you want just like don't even render this stuff just yet anymore, but instead go ahead and Love.graphics. Now we want to set the color to be red to detect the collision. So we're going to say Love.graphics set color. And the color we're going to set it is a full on the RGB scale, so 255, 0 on everything else, and then 255 on the alpha. Do we need not a string? Okay, yeah, just like that. That should be it. And then all we gotta do is say love.graphics. And we just need to draw a rectangle. So love.graphics, rectangle. And rectangle takes in a fill type. So rectangle, and the fill type is fill. We want it to be a solid rectangle. It takes in an X and a Y, which we know is our pit, X, and our pit Y. And then we know it needs a width and a height, and that is a tile size by tile size. So we got X, Y, width, height, and the fill mode. That should all we need to draw a rectangle. The last part of it is to spell graphics correctly. And then we can say if is pit collide, then render that rectangle. So it should only render that red rectangle if we're colliding with the pit. And it's just pit 1. But look at that. Oh, yeah. Okay. Sweet. So we got some feedback. So we know we're rendering collision with a pit 1. We need to scale the code so that it goes and checks every pit on screen, because we could have 80 pits on screen if we were crazy. And then, once we detect collision with a pit, we need to activate the gravity suck, whatever we call that. Probably not gravity suck, but we'll suck in the gravity. And then when it's detecting a is player 1 with the pit, trigger your fall animation. So we're getting there. We just got to cycle through all our pits. So let's see how we might do this. And this is like a decent time to commit to, though, but we will do that. Kind of want to try get fugitive. We should be able to say get right here, and we can say get status. I think we just do get status like this. Nice. Okay. That's cool. I wish there was coloring in get fugitive. Maybe there's a way to do it, but get... Let's do a get diff. Okay, we added a note. Oh, this is kind of colored. This is kind of nice. Okay, so yeah, we took off, made display 1. We, what? We changed our animation refresh. No, we didn't. Okay, yeah, we just changed that. We go to our class, we included inspect in our map here, and we can do like a little... Crap, how do I do it? Okay. Yeah. Okay, added all the looping for our entity defs. I wish I was able to figure out the better way to do that. We can come back to it. Okay. Yep, okay. Looks right. We can commit. So let's do get add all. Then get commit with a message. Get fugitive is kind of weird. We're going to say we added collision detection for 1 pit. That's what we did. All right, cool. 60 insertions, 5 deletions. Cool beans. We will push. Sweet. I don't know. I think I like it. It's nice that I can like still see my other code, but it's not nice. I don't have the nice coloring, because normally when I do that, I've got like the, well, we don't have it, but whatever. Let's go back. Not what I wanted, man. Oi, yoy, yoy. Okay. Sweet. Okay, so how would we get collision for all of our pits? We need to, take it out of this global crap. We have this global pit X, pit Y, but we need as many pit X's and pit Y's as we need, right? So like we need like a and a pit amount of pit x's and pit y's. So we need to go to our map. And we need to go... Yeah, we need to fix this. We need to fix this. That's fine, though. I mean, you know, AABB working. It's hard because, yeah, we need special variables for... Man, I'm a little bit at a loss for how to do this, but like it's simple. It's probably the 3 a.m. brain cracking in on me, but let's just first of all let's just loop through how many pits we got, yeah. Cause I'm trying to think if we just had one is pit collide. We still need to know which pit collides. Well, do we? It gets a little weird because if we project out, we do need to track the gravity suck. So it's gonna be called gravity suck at this point. But let's just try to loop through all our pits and see if we want to loop through all the values in a table. We can do the for key, comma value in pairs. And the pairs are our self pits, yeah? Is that right? In pairs, I think pairs needs this. That's looking right. Okay. So for key value in pairs self pits, go ahead and run the... Dude, this is it. This is how to do it. This is easy. Yeah. Because look, all we gotta do is come in here and say, okay, well, we need the x and y of the pit in pairs pits, but we want to say that the key will be which pit we're on, so we can put k in here instead. We could say for pit. Well, let's keep it here for now. Value, let's see, key would be the index, but value is the actual result of the... I really should know this. I want to blame 3 a.m. brain. Okay, so we're gonna say, you know what, we want a local pit. Ooh, no. We want a local pit x. Okay. Local pit y, and then in here we're gonna say, okay, well, now check our local pit x and local pit y for a collision and return pit collide true. Now we also, when we render, you know, we're doing pit x and pit y, what we really need to do is cycle through all our pits. that sounds so stupid. Okay, so let's do the for key value in pairs pits self.pits do, and we'll say, you know what, if we are pit colliding, then if we're pit colliding, render it not at pit x but v.pit.x. Nah. It's not on dot. What sucks? So like we're getting screwed here with closure, right? Because the local variable, we don't have access to local variable inside the pit object, so we're getting screwed. We would need to make... Yeah, we're getting screwed, man. We don't have access to the pit x. So, like, if we were to just say, okay, x and y is just going to be 0, top left, if we're pit colliding with either pit, then if that works, let's see. Yeah, not working. Okay. Oh, it works with that pit. So pit 2 is now working. Not pit 1. So like our... Either our... Oh, I get it. Gosh, if I could just find my own pits. Okay, yep, right here. Okay, so we're doing this is pit collide, which for pit 1 is true at first, and then it goes through to the second one, and then it says it's false for the second one. So is pit colliding gets turned false for the first one. It works only on the second one because that is checked last. So we need a way to keep track of multiple pits collisions, but we also need the track the X and Y of these pits. So we probably need a pit class, to be honest. Yeah, because we need a pit would have an X and Y, a is colliding, width and a height. So yeah, let's do it. I mean, it's gonna be easy. So all we got to do to add a class, let's check out our classes here. We've got a bunch of stuff. Let's just take a look at one class just to refresh my brain. We need pit gets class curly brace. Then we need an init function, a update function, render function. So let's just build that out real quick. So we'll go out here and we'll make us a new file called pit.lua. It will be a class of pits. So we say pit gets class curly brace. Now classes don't come in Lua. I'm doing a library that allows this to happen. So all we gotta do is say pit init. Is that all we gotta do? Pit init? I'm messing that up. Let's see our map. Pit init. That's all we gotta do. We initiate it with the thing. It needs an X and Y, right? So X and Y, and then a width and height is whatever. So yeah, let's do. Do we have to do function? Function pit init. Ooh, function pit init. End. Sweet. Function pit update. Because we need a trigger if it's colliding with a certain pit, right? So we need to pass in delta time. We have access to that. And then we also need a render function for our pit so we can see our beautiful pits. Actually, that's actually, we're not rendering the pit. The pit is actually rendered in the global map, the tiles. So the pit render would actually be the... We probably don't need this, but we would need it just to help us debug, say, hey, we're triggering a collision for a given pit. So now that we've got that, I'm just going to double check the syntax. Yeah, function, okay. So we know our pit needs an X. We're going to assign it to the parameter we pass it in. And our pit is going to need a Y. We assign it to the Y that we pass in. Now we know the width and the height, and they are both tile size, and I think... I've never done this, but I think you could do this. I think you can say two values here, and they are equal to the same tile size. And I think that's totally legit. And then we also need a self.is colliding, or self.collide is probably cleaner. Self.collide. We will initialize it to false. Okay, and then what we need to do is go. Our current collision detection is here in our map. Okay, right here. So we need this, but in our pit class. Okay, so how do we do this? Yeah, because we need every pit needs to be stored. Every pit object needs to be stored into a table for a given scene. So let's say we've got two pits. We need two pit objects. Now right now the dot pits just has a row and column. We should change that to an object of a pit. So we should go to our map declarations. Now we are doing some pit declaration here, and look at this. We're giving it just a table of scene row and scene call, which we can change. So we need to say, you know what we really need to do is table.insert a pit object. And the pit object, I shouldn't delete that crap before I looked at what I was doing. Yeah, so we've got a call and a row, a scene call, scene row. Okay. So what we could do is take our pit. We don't have access to the X and Y. We have to calculate, right? So what we can do is pass in the scene row, scene call, calculate it in the pit object instantiation, in that init, and then we're able to have that X and Y value. So we'll say here that, you know what, we're going to pass in scene row as the first argument, and we're going to pass in scene call as the second. That's the only arguments we need, because is colliding is going to be set to false. And as long as are we importing pit here? I think we have access to it. Ooh, pit a nil value. Type the global a nil value. I think we do need to require a pit. Okay, that's fine. That's fine. That's a different error. So what we do need to do is go to our pit, which we don't have harpooned at the moment, but we can go harpoon it so we have access to it. Now this is actually scene row, right? Scene row. Now this actually doesn't need to be the same values, I don't think, but let's just make sure we're using it. I believe we did scene row, scene call. Let's make sure. What music you listen to. I actually programmed this music in Sonic Pi. So I've got the code right here, and it's running live as we watch here, or as we stream. So this is the code that's running live. And yeah, this is, we got 30 lines of code, and it's just an ambient loop I programmed. So if you're interested in that sort of stuff, it's called Sonic Pi. I think Sam Aaron is the one who created it, and it's totally free. Works on Linux, Windows, Mac. They got some great documentation for how to do some examples. So even if you're not too musically inclined, you can get started and try to do it. It is really cool. I do recommend it. Yeah, I like it because it's chill and ambient, but also it's never the same. It's always random, so I think that's kind of cool. Okay. So what, are we crashing arithmetic on field call a nil value on map 86? So let's see map 86 here. Yeah. So let's just comment this out. This is the old way, because now we need to calculate this stuff in the pit object itself. So we can come in here and we can say, boom, X and Y is the column and whatever. We can go back to our pit and we can say, okay, X and Y is not scene row. X and Y is going to be the X is call. So X is scene. X is scene call. Yeah, scene call, the argument we pass in as the scene call, times 16 to give us the offset, and then minus the 1 index offset error. And then this one should be scene row times 16 minus 16. Okay. Width and height, same for every pit. The init for the collide is also the same at a false. So now we should have pit objects inside. Do you have the music script on GitHub by any chance? No, but I can do that. I can do that right now for you. Yeah. Here, I'll make a git repo real quick and post it up for you so you can peep it. It's a good idea to have it just in general. Let's do it. It'll be easy. Make a new repo called Sonic Pine. All right. Sweet. You got a repo. And what I'm going to do is give us the repo locally here. And we will... I shouldn't have done that. What we'll do is go over here to our next window. And we will git clone the repo we just made. Sweet. We'll cd into our Sonic Pi, and then we'll just we'll make a file here called great progress, by the way, watching your recordings on YouTube. Oh, thank you, I appreciate that. Yeah, I do post all the videos on YouTube. It's mainly just to, you know, I just like seeing my progression and seeing, you know, I try to stream every single day, so that's why I am coding late today. But we'll call this just what, stream, I don't know, stream 1, I don't know, stream 1. It'll just be a text file, I guess. Okay, and then I'll just put up the code here. And I will paste it. That looks like it. All right, we wrote, we quit. We need to get add all. And then we will commit with a message saying added stream 1 or Houseberg. Okay. Boom, it's get pushed. So I'll send you the link here, github.com/findingfocus/Sonic Pi. That should be it. Yep, and then it's just stream1.txt. So you can plop that into Sonic Pi yourself and run it, do whatever. But yeah, super welcome. I'm glad you're interested in it. It's cool. I've been meaning to... Thank you, Shaky Coder. I appreciate that. That's awesome. I've been... you know, it took me like 3 years to hit 100 subs. And then I got like 60 subs this past month. So it's been really crazy to see. But I appreciate all the love I've been getting over there. It's really cool. But yeah, thanks for the suggestion, Hausberg, because I've been wanting to make a repo for that. So yeah, it was easy. Okay, we've got a pit. Now we need to, we should have multiple pit objects. Videos got recommended, probably the algorithm. Yeah, I don't know what, it just kind of started, you know, I mean, no one, they're long, 2-hour devlogs, like no one, I mean, I don't know how many people are actually watching them, but if, I don't know, it's been cool to see people actually comment. So like people have been commenting saying it's cool and people like it, so that's been really awesome. I think what I want to do is print up my .pits now that they're pit objects and see that. So in our map, we should, let's see. I think our self pits. So our self pits now is getting our same .pits, but our .pits is not anymore a table of scene row and scene column, but now it is a pit object with an X, a Y, a width, a height, and a collide. So that's what I'm hoping to see when we print up our self pits now. So let's go and see here. We will say, let's turn this back on. And we'll say we want to print up, oh, not this. Let's just do another one. We'll say love.graphics dot print, and we're going to be printing up the self.pits, self.pits at a 1010. Why not? Let's see our pits. Should be an object. Ooh. Love.graphics.print self.pits. We've got a self.pits. Yeah. Inspect pits. That sounds so silly. Let's inspect our own pits right now. Okay, that worked. Okay, now we don't get to see. Oh, you know what? I got an idea. I don't know if it's worth it. I kind of want to like add drop shadow to the print, right? So we can say, you know what? That's the white. Oh, we have to render black first. So let's try this. Let's see if the drop shadow idea will work here. We'll set color to black, which is just 0, 0, 0, and 255 for full transparency. So set color to black, and then first render black. Then we're going to set color, and we're going to switch to pure white. And then what we're going to do is then render the same thing, but at 1 pixel up and to the left as our black. So we'll go from 1010 to 99. And then maybe we'll be able to read it better with a little bit of drop shadow. Cool. Collide false with 16. Cool. So, what's going on with this metadata stuff? What's cool is our pit now has like access to that. You know, we're calculating the X and Y in the pit object upon the init. So that's kind of cool. But then we've got this like metadata table that I don't know. What's after, you know, why is it collide false first, then width, then XY, and not height or anything? Metadata table. Okay, so maybe this is kind of screwing something up with that metadata table stuff. So I'm gonna get rid of it and see if it makes that table a little more concise. I don't know for a fact that works. I was just thinking. No, yeah. Okay. Well, now we've got the width and the height in there. Metadata table. What else are we putting in there? Is the dot collide? It's just those 5 values. So it's just another. Oh, yeah. It's just the other pit. It's the other pit. So if we go in here and we say, since we did table.insert, every self.pit should have an index. So we should be able to say. Not that. We should be able to say index 1. And then index 1. And then we shouldn't have that second metadata table. Ah, we do. What the hell is that metadata table? I don't know, but we've got the right values. So I think it's working. So we can just treat it as if it's working, because I think it's working. So we know we've got the pit objects now, so that's cool. I'm like the king of doing this, just leaving uncomment out code in there for 50 commits. But let's see now. I guess this would be in our I think it would be. We need to re-add the collision based on a per pit variable, as well as render the conditional collision detection inside the pit object. So we're just going to say here, let's just add this render for the successful collision. And we're going to set the color to be equal to pure red, which is, this is RGB, so 25 is perfectly red, and then 0 on the green, 0 on the blue, 255, and then we're going to say, you know what, we're going to render a square. We know how to do this. We need to give it a fill type, and then a x and y, which is going to be our self.x, self.y, self.width, self.height. Okay. And right now we should be, we're never rendering the pits, which makes sense. We're not, you know, we have a pit, but we are not rendering it. We have a render function. We are not calling that render function on our pits. So let's go to our map and we'll say, you know what, last thing we're gonna do, we're gonna just blatantly render all our pits. So we're gonna say for key value in pairs, this is how we just do multiple table stuff. We're gonna be running pairs of what? Self.pits? No, yes, yeah, self.pits. That stuff sounds so silly. Okay, for every pit, we're gonna go render it. So all we gotta do is say the value of every loop, which is gonna be every pit. We're gonna just say, you know what, render that value, render that pit. Let's see, we should have 2 red squares. Yeah. Should have 2 red squares for every pit. Sweet. And then if we go over here, we're not shifting our red squares based on a scene transition, which has to do with a offset X and offset Y for a scene transition. We can, since this isn't necessary to the function of pits, this is just to help us detect collision. We won't need that. We don't need to worry about that. But so like now, instead of just rendering it willy-nilly, we can come in here to our pit and say, you know what, we only render this if our self.collide is true. What did I do? Okay, if self.collide, then go ahead, render our pit. And we're gonna say, cool. If we're colliding, go ahead, render it. So if we run it now, no red square because we are not colliding. But if we come in here to our map and we would say, let's just go over here and we're just gonna say self.pits index1.collide gets true. And then like this should be the left pit, should be red. Cool. And then if we swap it to 2, it will be the right one. Sweet. And then this one would probably crash. Yep. Cool. I like when I know that it would do something. That's nice. Okay. Sweet. So now all we have to do is run the what do you call it? The AABB collision inside the class. So we're really close here. Let me just block this dude real quick. Okay. We're close. We're doing good. We're doing good. We're gonna go over here to our pits. This is where we need our collide logic, which we had built out already over here, and we commented it out right here. So here's our very simple collide. Oh, this is gonna be so nice. This is the way to do it. Cool. So we aren't giving a reference to our player, but we do have a global scene view that we do have reference to our player's X and Y. So we do still have to pass this in like this. But this pit X would now be self.x, and a tile size would now be a self.width. Oh, it's late. It's late. Okay. And then this would be a self.x. And then scene view player y smaller than self.y. And then this would be self.height. And pit y is now self y. Sweet. And then instead of the is pit collide, say is pit collide, we want to change that now into self.collide. And then let's see. We are not rendering our pits. Or we are and we messed something up, but let's see if we are rendering our pits now. We are rendering our pits, so what's going on? We are messing something up. Pits. Are we updating our pit? We are not. We are not updating our pits. Yo, we need to update our pits. So we'll do the same thing here. And we'll go into our update function in our map. And we'll go plop them in there. And we'll say, for all our pits, don't render. Update. And pass in delta time while you're at it. Let's see. Oh, baby. Oh, yeah. Heck yeah. So now we just need to trigger our falling. You know, I mean, for right now, we could do it based on if you collided with switch from Arch to Zorin. Yo, I've never heard of Zorin. I haven't tried Arch, but I've definitely heard of it. But I've been looking into NixOS because that seems like an interesting concept. So I'm kind of interested in that. But Gustavo Fring, good username, homie. That's awesome. You know, I'm in Albuquerque, so I basically live Breaking Bad. You should see the cars in my parking lot. Like, their windows get breaking like every day. This is cool. Okay, so we've got collision detection for all pits. That's cool. We are still not. We're not triggering our falling animation based on any sort of collision, but we've got the collision there, which is really sweet. I like it. This is sweet. Well, you know, and what we can do and should have done is make a general purpose collision for any given tile ID, and we can just pass in which tile ID we want to check collision for. It's something I've just heard about recently. Like, apparently you can make, I'm gonna butcher it, but it's like you can make like a, you know, you do all your configuration once, and then you can kind of save that config file so that on any NixOS distro, you can just load in your config and have all your stuff just like, you know, the same. So that was kind of interesting to me. I used to stream on Linux. It's just that I couldn't get good CUDA drivers for my graphics card, so my stream was just crapping out. So I had to switch to Windows, which I am just bummed about. But I do like Linux. I used to stream on it. I miss it, but I just can't pull it off with streaming, and the Stream Deck doesn't really work on Linux. So I'm here. Okay. You know what? This is great. This is big progress. We need to start adding the gravity suck, because if we stand like right here, it should know that we're standing like kind of over the hole, and it should pull our center towards the pit's center. Nice. You know, I'm gonna look into Zorin. Like, are you you liking it so far, or are you for sure switching to it, or are you just giving it a test drive? I mean, I guess you have to test drive it before you commit to it. Yeah. So let's go to our notes. We will say, and where did my notes go? Okay, we will say add gravity suck upon pit collide. And then we need to trigger fall animation. So it's like we need two kind of collision detections. We need a collision detection for I'm on the side of the pit and I'm falling in, and then I've fallen so far into the pit, we need to trigger the falling animation. Now, like kind of like in Link's Awakening, right? Like you can walk a little bit into the pit, it'll start to pull you, and you can, if you walk, opposite direction, you can get out of the gravity. So it's going to be fun to kind of play around that. And then once we trigger the falling animation, we need to add damage and set flashing for player. And then we also need to respawn our player. That's going to be a little tough because we have to decide algorithmically where does our player come back once they've fallen in a pit. Like we could, it depends, we could have a pit that is, you can only insert, from the left, you can only fall in from the left. So if we say anything other than you fell in where you came from, that could screw some stuff up with collision detection. So that's going to be an interesting puzzle to solve. Respawn player in safe spot. I mean, I guess what we could do is kind of, I really don't know an efficient way to do that. Like we could, every 2 seconds we can save the player's last position 2 seconds ago or something. And then once you die, you just go to where you were 2 seconds ago. Maybe that's a decent way to do it, because your player would only be in a legal spot if you were walking, right? So like we would know we wouldn't spawn them in a forbidden spot using the algorithm that way. So maybe something like that. And then say for legal respawn, I guess. Sweet. Okay, sweet. So what we did, and I'm gonna do what I almost never do, is go and delete those comments that I just left, because we don't need to be committing those. We don't need this one, right? Like, that one shouldn't be in there. We can leave... I mean, this is working. This is working, so I'm not worried about this. Sweet. This is big. This is big. I mean, it's simple, but it's nice. And then we've got it where the pit is transparent. So like this pit is on a darker green grass, but this pit is on a brighter green grass. So we can even put a pit in the sand if we want. Yo, yeah, Gustavo, you are the first person to call that out. It's actually not Sekiro, but it is from Sekiro. So it is actually Sekijo, the sculptor, as he was young. And this is Kingfisher in the background. So it's like a Sekiro lore picture. But yeah, you were the first to kind of point that out. I don't know if you've seen the stream before, but one of my friends, I commissioned this from one of my friends, and he's really good. So it definitely is Sekiro, but this is the sculptor. You know, orangutan back in the day, and then, yeah, right. He did such a good job because like it oozes Sekiro, right? But it's not overtly. I mean, it's original, right? Like this is in the Sunken Valley. You know, you can see this stuff, and then he put like the lore. Like we don't know, you know, we don't know much about Kingfisher other than, you know, they used to train in the Sunken Valley together, and she's blowing on the finger whistle back there also. I don't know if I can zoom in. I don't know. Is there a... Oh, crap. Did that screw up? I don't know if you're able to see that, but yeah. That is my friend Salto Manga, who you know, I commissioned for the art, so he's a friend of the channel. Here, I'm gonna do a shout out real quick. Yeah. But yeah, I love the art. I think it's awesome. I love Sekiro. I think it's one of the greatest games. Oh my jeez, that scared the shit out of me. Thank you for the follow, Gustavo. I appreciate it. That really freaked me out, man. I gotta turn the volume down on that. Was it loud for you guys too? Because that freaked me out. That gave me a little heart attack. Collision detection for pit class objects. That's pretty sweet. Okay. I'm glad I'm not the only one. That really freaked me out. I'll turn it down. But also it's kind of funny. Sweet. We get pushed. Sweetness. I'm gonna see. I'm on a stream team for indie game devs. I like to raid out when I can to some team member, as long as they're actually programming games. So I'm gonna make sure someone's programming games here instead of just playing games. And
is there anything else I can use?
I mean, we've got one friend. So I'm gonna raid out. But hey, thanks everyone for hanging out. I appreciate it. It's a late night, at least for me. But we will raid our team member here, Wolfric. I'll give him a follow when we go in there. But thanks for watching the channel. If you're interested in the backlog or anything, it's on my YouTube, Finding Focus on YouTube. I try to stream every night at 7 p.m. Mountain Time. Today was a anomaly because I had to fix my computer, but my CPU seems stable. We had a hour-and-a-half stream with 0 drop frames, so I hope everyone has a great night, and thanks for watching. I really appreciate it, and I'll raid out. Peace out, everyone.